Good afternoon. So I wanted to do a quick video for you guys to explain to you the method of completing the square to solve a quadratic equation. So I'm going to look at the lecture notes, and we didn't get to these two problems, so I'm going to use these two problems to demonstrate the method. So in the lecture notes for section 1.4, our first complete the square problem is x squared minus 6x equals -1. So in this problem, you notice that it is in the form x squared minus x equals, and your constant is on the right. So whenever you use complete the square to solve a quadratic equation, you do not want it to equal 0. You want it to be set up just like this, so that your x squared and your x term are on the left and the right is your constant. So the next thing that I'm going to do is I'm going to insert some spaces, one on the left and one on the right. So what we're going to do is we're going to actually add something into this space on both the left and the right hand side of the equation. Now, what we're going to add depends on this middle term. So you see this coefficient is -6. So we're going to have -6. So I think we agree that half of -6 is -3. So that's what we're going to add in the space, except we're going to square that -3. So I'm going to put -3 squared on both the left and the right. Okay, so really, if I were to square this -3, this would be x squared minus 6x plus 9. So if I were to factor x squared minus 6x plus 9, I would get x minus 3 times x minus 3, which is x minus 3 squared. Okay, but the beauty of using the parentheses like we did earlier is that you can just go ahead and copy down what you added in the parentheses, like so. And so you can see that your left-hand side becomes x minus 3 squared. So again, if you were to FOIL this back out and say x minus 3 times x minus 3, you would get x squared minus 6x plus 9. Okay. And then, of course, we're also going to simplify this side. So this is secretly also 1 plus 9. So this side is going to become, or excuse me, -1 plus 9. So this side is going to become 8. All right. And so now we can continue solving this problem by using the square root property. So the square root property says that if I have a term that's squared equal to a constant, then this term is equal to the positive or the negative of the square root of this constant. So therefore, x minus 3 is equal to the positive or the negative of the square root of 8. Okay, so to continue solving this problem, we do want to simplify the square root of 8. Now, 8 is not a perfect square. However, 8 has a factor of 4, which is a perfect square. So we want to rewrite this 8 as the square root of 4 times the square root of 2. So now we have x minus 3 is equal to the plus or minus of the square root of 4 times the square root of 2. So the reason that we do that is because we can find the square root of 4, which is 2. So we're going to apply this square root to the 4, and we won't have a square root symbol, we'll just have a 2. So this side will become 2 times the square root of 2. All right, now we're almost there. We're not solving for x minus 3, we're solving for x. So we do need to add 3 to both sides so that we can isolate our x. So if we add 3 to both sides, we now have x is equal to 3 plus 2 square root of 2, or 3 minus 2 square root of 2. Remember that plus or minus really is two different things. Okay, so that would be this problem. All right, one more thing I want to discuss about solving for quadratic equations using the complete the square method is that it is really important that your lead coefficient be 1 when you're using this method. I think I'm going to turn the board the opposite way for this problem. So we have 4x squared plus 8x equals 16. And we want to solve this using a complete the square methodology. Now this is in the correct format almost, because we do have the x squared term and the x term on the left, and we do have the constant on the right. However, there's a 4 for our lead coefficient, and when you use the complete the square method, you need to have this be 1. So what we're going to need to do to fix that is we're going to need to divide the whole equation by 4 so that we can make this into a 1. So if I do that, now my equation becomes x squared plus 2x equals 4. Okay, and so now this is in the proper format so that I can use the complete the square method to solve it. Okay, so I'm going to insert my spaces. So x squared plus 2x, I'm going to add a space on the left, and I'm going to add a space on the right. And what am I going to put in this space? Well, I'm going to look at this middle term. I'm going to look at the coefficient on the x. It's positive 2. So what's half of 2? Well, 1. So I'm going to put 1 squared on both sides. Of course, I know 1 squared is just 1, but so that we can have the same method every time, I'll go ahead and put it in parentheses anyway. All right, so if I were to factor x squared plus 2x plus 1, I would get x plus 1 times x plus 1, which is x plus 1 squared. And so now I've completed a square. In other words, I've made this side of the equation now a perfect square. And if I simplify the right-hand side, of course, I get 4 plus 1, which is 5. So now I can continue using the square root property, which once again says, if I have a term squared equal to a constant, then the term is equal to the positive or the negative of the square root of that constant. So if x plus 1 squared equals 5, x plus 1 will be the positive or the negative of the square root of 5. Now this time it's a little easier than the previous problem because 5 is not a perfect square, and it also doesn't have any factors that are perfect squares, so this is already simplified. So to continue, I just simply need to subtract the 1 off of both sides, and just for clarity, I usually am going to put that at the beginning. So x would be negative 1 plus or minus the square root of 5. And again, if I'm in WebAssign, I want to separate that out into the plus or minus portion of the answer. And so those would be my 2 answers to this quadratic equation. Okay, that's the complete the square method. You guys have a great afternoon, and I'll see you next time in class.